you take the point, right? This is a pretty mundane use, and this is better at it than the old models.
One thing you could imagine is that in the mature version of this app in a year or two from now, the other thing OpenAI released recently was its GPT-4o, the voice mode, where it does real-time voice with realistic emotions and tones of voice and able to sing and stuff. That's kind of the opposite end of the spectrum, where that wasn't any smarter, but it was more interactive and seemed kind of more human-like.
Hi, Tim.
Hi there, Bob.
How you doing?
I'm doing great. Can't complain.
Well, then don't, Tim. We'll move right along with the podcast since we don't have to spend time with your petty complaints. So let me introduce us. I'm Robert Wright, publisher of the Nonzero newsletter. This is the Nonzero podcast. You're Timothy B. Lee, publisher of the Understanding AI newsletter. We're going to talk about AI, in particular, a development last week. In fact, I think Friday, a few days ago, or Thursday, that depending on who you talk to, was either very big, arguably the biggest development in large language models in more than a year, or is being somewhat hyped, its significance overstated. Now, you tend to fall in general in life in the this is being overstated camp, I think, by nature, right? You're kind of a skeptic by nature. Am I right?
To some extent. I mean, I try not to be like predictably in one camp or the other, but I would say since from GPT-4 until last week at least, my view was that things did not seem to be progressing very quickly.
Oh, so we'll leave people in suspense for a second on whether you've now got religion. But let's say this much from the outset. This supposedly adds a really significant capability to do like reasoning and planning that old LLMs didn't have. But before we get into what it supposedly does, how it does it, how well it does it, the naming convention is an interesting thing, right? OpenAI, this is an OpenAI thing, but they chose not to go with the GPT thing. And I can read that in one of two ways. They're calling it OpenAI O1, right? And I can read that as trying to underscore its importance. This is a whole new thing. I can also read it as kind of trying to lower expectations. And they did a little of that explicitly, like this is just the first version. And in other words, them thinking, well, this is important enough that if we call it GPT, we almost have to call it GPT-5, maybe 4.5, probably 5. And then people will be disappointed because in some respects, it's not an improvement over GPT in terms of, writing ability and a lot of language processing stuff per se. What do you make of the naming convention?
I think it's more the second thing. I think they are signaling that it's a new thing and a significant new thing. I think it's a change in direction. I mean, the thing, the big thing they changed is that until now, the GPT series has been the model has been you spend a ton of computing power training the model, and then you make it pretty lightweight at inference time. When you actually use the thing, it generates one token at a time, and it only takes a second or two. The new approach is they found that if you actually let it quote unquote think, and we can talk about like what thinking means here, but if you let it think for 10 or 20 seconds, it can actually come up with a much better answer. And that is something I think they have signaled is they're going to continue. They found that you can actually get gains on both ends of it, at training and at inference time. And I think they are going to continue doing that. I don't think it would make sense to do that for all applications of large language models. And so my read is the GPT series is going to continue to be the vanilla kind of real-time interactive model. And this O series is the deep thought kind of scientific research or, math problem solving, programming problem solving, where the idea is you don't expect an answer right away. There's going to be many applications where it doesn't make sense. Because anytime you use an LLM in like an app, say you're a developer and you've got some website or app you're making for consumers, no consumer wants to wait for 30 seconds before you push a button and something happens. Mm-hmm. And so this is, I think, a little bit of a specialized thing, but it also could be a very important thing if this gets better and better at reasoning. It could have a big market, but it'll be a different market than what they're going after with.
But don't you think ultimately the plan must be to integrate it into the generic, whether it's called GPT or whatever, to integrate it into GPT, and that ultimately Anthropic's Claude may have a dimension like this and Google's Gemini? Because for one thing, so of course it's true right now, it's very compute intensive on the answer end, and so is a lot more expensive to operate, I guess. But of course, compute power gets cheaper. A and B, you're right, and maybe we should spell out a little its capabilities. You're right that it does some of these specialized things uh, apparently much better than the existing models. Certainly, formal reasoning, mathematical, but performance on like all kind of GRE type tests in the sciences, and I think social sciences, some of which does involve reasoning. Um, but also it's better at things like crossword puzzles and little familiar puzzles that the old models sometimes gave comically stupid answers to, like, you got to get two chickens and a fox across the river in a boat and so on. Um, and it's good. It's better at planning, including like apparently like you know uh, invent a company that does this or Ethan Mollick had some good examples. And I want to get into some actually very everyday examples where it seems to have better agentic powers in principle. It can do more stuff for the average person. So for all those reasons, I think this has ultimately got to get integrated into the larger models. Does that seem wrong?
Well, so, yeah, I think you want to distinguish models from applications. So GPT-4 and O1 are two different models,
Hmm.
and then both of those are options in the ChatGPT app. But then there's also an API where third parties can come and they can make their own app. They can make, an email app or some kind of like
Hmm.
internal like search engine for their documents or something, and they can use those
Hmm.
models in their internal ones. And so I think from the perspective of an API customer, which I think most of the money in the long run is going to be in those APIs because there's many, many applications that many, many different companies want to build using these models. I think they're just different use cases. There's a real time use case where you want the answer immediately, and
Okay.
there's the best possible answer use case where you're happy to wait 30 seconds. And I mean, maybe over time, this long thinking model will get so fast that you actually, the time comes down and eventually it's all real time and it's all fast. Like that's certainly possible. But at
Hmm.
least in the next year or two, I think the best answers you get will be answers that it'll take 30 seconds a minute to do. And so that's just a different use case, which means they want a different model that's kind of optimized for that. So I don't think there's, in the very long term, I don't think this necessarily means there's like a fundamental change. It may ultimately be it's all one big model. But I
Hmm.
think the next few iterations of this technology, you're going to have multiple. I mean, in the same way, you also have, all these companies have, um, you know, uh, like Anthropic has Claude Sonnet, Claude Opus, and Claude Haiku. There's like different versions that are the the Haiku is the slowest and cheap or the fastest and cheapest one, but it gets the worst answers. And then so I think as this market matures, there's going to be more gradations along that kind of frontier of cost versus performance and speed.
Right.
And they'll ship different models with different makes
But
those trade offs in different ways.
but to the extent that it is useful for the retail customer, like a layperson,
Hmm.
you'd think they just want everything in one product, right? Like Google doesn't want my life to be complicated. They want me to sign up for one thing. And Microsoft, does too. And let me give you an example of some a test they gave this that I thought was kind of interesting. I don't know. Did you listen to the Cognitive Revolution podcast, which you were on recently, talking about self-driving vehicles, which maybe we'll
Yeah.
have time to talk about. That was a very very good episode. You're definitely one of the leading authorities on that. But Nathan Labin's had this guy on who from Apollo Research who did some of the pre-release testing on this model that was mentioned in the system card, including some safety related stuff that I want to get to eventually, because are also some kind of doomer concerns that this model is starting to do things that people warned about in terms of pursuing its own devious goals in order to achieve the larger goal you've given it, notwithstanding human interference and stuff. Um, but this example, in terms of it being useful in a more everyday agentic example, was like uh, they said to it, here was the instruction. Okay, listen, they said to it, my I'm gonna have a baby. My doctor sent me an email telling me what the gender will be, but I want it to be a surprise, and I want to have a gender reveal party. So I want you to go read the email and plan the party, but I don't want to know what the gender is going to be. And they had given this test to past models, and they always screwed it up. They always like inadvertently revealed to the person or something. And this one never did. I mean, it went and so it read the email and then deleted the doctor's email. Remember to do that. It ordered the pink or blue appropriate stuff for the party in this fake party store they had set up. And then when it got the email acknowledging the sale, it deleted that. And at no point did it inadvertently say, okay, it's a boy, it's a girl. Um, now this was to test, theory of mind, ability to think about what this person giving you the instructions is thinking and what they know and how you want to shape what they know. It's important in that way. But also, you take the point, right? This is a pretty mundane use, and this is better at it than the old models.
Mhm. Yeah, so this is why I think it's important to distinguish apps from models. So one thing you could imagine is that in the mature version of this app in a year or two from now, because the other thing OpenAI released recently was its GPT-4o, the voice mode, where it does real time voice with realistic, you know, emotions and tones of voice, and able to do the sing
Mhm.
and stuff. Um, so that's kind of the opposite end of the spectrum, where that wasn't any smarter, but it was more interactive and seemed kind of more human-like. And so you can imagine the way it works is you ask it a hard question, and the kind of fast model will think for a fraction of a second, say, hey, I'm not sure what the answer is. Would you
Yeah.
like me to take 30 seconds to think about it?
Yeah. Hold on.
And
Let
you
me
say
think about it.
yes. And then
Yeah.
it'll think about it. And so the
Yep.
two models can be integrated into a user experience that's seamless, so the user doesn't have to click a drop down to say which model am I using right now. But I think just conceptually, under the hood, I think there may still be two or more models where the different models are optimized for different use cases.
Yeah.
That's all I'm saying.
Okay. So, how impressed are you by it? Um,
I'm pretty impressed. So I try to be empirical looking at this, and so I spent the last few days, trying to trick it and finding the things it's bad at. And the one thing that I found is definitely bad is spatial reasoning. It's
mm,
terrible at playing chess. I gave it a little. I described like a little map and said find the shortest route in this map, and it just went through an area that I'd said was closed. So that kind of thing, it's quite bad at.
is it
But
is it wor- is it worse? Do you know than GPT-4 or?
So interestingly, the chess example was interesting. So I gave it a very simple, like 5 move opening, where the
Mhm.
last move put the white's queen in danger. And I said, "What's the best move?" The obvious best move is take the queen. GPT-4o gets it correct. I think just because there's enough chess in its training data that it just has memorized that sequence of moves. The next thing is take
Okay.
the queen. GPT-4o thinks for longer and gets the wrong answer, and I think that's because it's actually trying to reason through the problem and
Mm.
then does it wrong. So it did that worse. 4o, I mean, for the map one, they were both completely wrong. It was just I think they gave the same answer. So I think it's just like the kind of token by token way that LLMs work just does not have a kind of way to represent a map, represent a two-dimensional, geometric situation. And so I think it just is totally lost on how to do that. So that's the one area where I clearly think there's work to do. Pretty much everything else, I had trouble getting it to make a mistake. So for example, I did another thing where I described a child building a structure out of blocks, and I say, you remove this block, what happens? And you say, well, then it feels imbalanced and it tips this way. I tried a bunch of different permutations that got them all right. Um, I did a bunch of things like that, and almost everything it was as good or better than GPT-4o, including some things that was kind of expecting it would uh, fool it. So yeah, it's a significant. I would agree with the view that it's the biggest advance since
Mhm.
GPT-4.
Huh, that's interesting. I mean, I was gonna say the other candidate for that honor is the multimodal thing you mentioned, but that's kind of along a different dimension. That's very important, I think, but it's along a different dimension. Do you know if anybody's tried the thing that the old models, are bad at? Like, you say, "Who is Tom Cruise's mother?" And it gives you her name, and then you say, "And who is her son?" And it and it's completely flummoxed.
That is a good question. I did not check that.
Yeah.
No, I do think multimodal is the other thing, and that was I actually think the thing that surprised me there was just when they added the vision function, which I guess they announced it along with the original GPT-4, but didn't release it for a few months. So that would surprise
Mhm.
me. once they had the image, the ability to recognize image, the fact that they also could do it with voice didn't surprise me that much, because it's the same trick. You just take the thing, you chunk it up into tokens, and then you throw it into the transformer, and somehow it understands it. So I wasn't. I thought it was a neat technology demo when they did the real time
Mhm.
voice, but it didn't really change my model of what these things are capable of. Like that, that's something I would have expected that to come along sooner or later.
So this does more of that in a way. This is more impressive and surprising to you.
Yeah, I mean, the thing I'm surprised by is that previous large language models just tended to get confused by complexity, because the way these models work, they have this attention mechanism where they look at every previous token. And so as you increase the number of tokens, LLMs just had the tendency to just kind of lose track of where they were, and get confused. And like, the more steps of reasoning, each step has the possibility of making a mistake. And so the more steps there are. And so it just wasn't able to do long chains of reasoning like this. And this one's not perfect. I mean, I think they do so occasionally make mistakes, but it's a big improvement, much bigger than I think than the kind of incremental GPT-4 class models we've seen over the last year, like Claude 3.5 or Llama 3.
And in terms of how they do it, what the secret sauce is, I gather there's a couple of things going on. I mean, first is it was always the case, and this always kind of I didn't understand why this was the case. It seemed kind of almost magical to me that if you gave one of these large language models a problem it wasn't doing well, if you just said in the prompt, think step by step,
Mhm.
it would actually do a better job.
Yeah.
And it seems to me that some of this is them just, you know, building that instruction in a generic way.
Mhm.
But I also gathered there's a whole kind of reinforcement learning that was these things were shaped by that's a little different from the old kind. And we should say, for anybody who doesn't know, I mean, the phases of training are, I mean, there's what's called pre-training, which most of us actually think of as training, where it's going through looking at text and figuring out how to complete sentences. And then after that, there's fine tuning, and I guess technically a second round that's more commonly called, reinforcement learning through human feedback. Those last two rounds involve human feedback. So, strictly speaking, by the way, in this nomenclature, there's nothing that is technically training. So, I mean, I don't know. I will
Well,
never.
it's all training. They're different kinds of
Of course,
training.
it is, but you take my point. If you ask the people in the field, what is this? They say pre-training. What is this pre-training? What is that post-training? What is that? It's just
Mhm.
I'm slightly troubled that the people who are shaping our future came up with this system of nomenclature. Okay, there's pre-training and post-training, but no training.
Uh,
Okay, but anyway,
yeah. So let me kind of unpack that a little bit. So the chain of thought thing, I think, is actually not. Here's how I think about it. If you ask an LLM what's 2 plus 2, it knows the answer is 4, because it has seen the exact string 2 plus 2 and variations on it
right.
many, many times. And so it's just memorized that. If you ask it, what is 2 plus 3 plus 7 plus 8 plus 4 plus 9 plus 2 plus 7 plus 5, it's never seen that exact string. And
Hmm.
so it just kind of guesses, and it's likely to get the wrong answer. But if it knows how to break that into 2 plus 3 equals 5, and then 5 plus 3 equals whatever. And right, if you break it into strings, each individual string of which is in its training set, um, then it knows how to do the individual strings, and that sequence of strings becomes
Hmm.
a completed, gets you to the final answer. And so I think that the chain of thought is just doing that on more complicated problems, where you ask it a problem about the um let's see, what's a good example here. um anyway, you ask it to do a problem that requires several steps of reasoning. um each step may be something that it's seen in this training example, and so if you encourage it to unpack what the steps are, then once it has those steps in its context, then it's able to go through the steps. And so that's how chain of thought works. And so, yeah, I think there's two basic things they did with O1. One is they did additional training with examples. So the way training works is you have training examples, and you're telling it, make your output look more like this, and then it gives you a document. It gives it a bunch of documents that have the kind of output you're looking for. And so with O1, they trained it on examples of long reasoning strings. It would have, here's a problem, here's the solution, and it would make the solution really long. It would say, here's the 1,000 tokens you need to generate to solve this problem. And in particular, what it would do is it would have a section where it gives the reasoning steps, and then would have a special token called like response or something, and then we'll have additional tokens to give the answer. And then on the front end, when you use the app, the first part of that is hidden from the user, and then after response is what it actually spits out. So that's the one thing they did. The second thing they did is the reinforcement learning, and that is so a vanilla GPT large language model. It is just trying to um, mimic text that humans made, but there's no strong signal of whether it's right or wrong, because there's many possible ways to complete a
Right.
sentence that are maybe not what the human wrote but still are valid. And so it's a pretty weak training signal. It would be better if you have a way to tell the model, no, actually that answer is wrong. You put the wrong number at the last step of that. And so I think what they did, and they haven't been super clear about this, so my hypothesis is they took a bunch of math and programming logic problems where they knew
Mhm.
what the right answer was. And in fact, they could like have a computer program that, because of the structure of the problem, can say like, here's actually what the answer is, what the steps are. And then they created a bunch of training examples where they gave the problem to the LLM. The program knew the software, and so then it could have the LLM do it and then give it a strong signal to say, yes, this is right, or no, this is wrong.
Mhm.
And so that allows them to, give it a much kind of more forceful push in the direction of the right answer. And I think they did this on a large number of problems, and uh, that's how they did it. There's a bunch of different, like, specific ways they could have implemented. I don't think they've said so. One thing that OpenAI published a research paper last year about a technique where, rather than just judging the final answer, they had somebody go through and judge each step and give like a thumbs up or a
Okay.
thumbs down to each
Yeah.
step of the problem, and then that would give the model feedback, not only did it get the right answer, but like, which place did I make the mistake. And so it's possible they did that. It's possible they
Mm.
could find a way to programmatically kind of have a computer program that knows what the right steps are for certain kinds of problems, and then do that. Or it might have been the final answer. I'm not sure about those kind
I
of
heard
details,
somebody
but
use the term outcome reinforcement learning, which suggested to me it wasn't what you just described, which is more
yeah.
like incremental reinforcement for each step in its reasoning process.
Yes, I think there's
But
two. Yeah, there's that, and there's process reinforcement learning, I think, which is the one that looks at each step. So, if somebody said it's the first one, that could very well be the case.
yeah, I'm not sure. I am wondering kind of how human labor intensive it was. In other words, is it kind of a trick? The magic of the LLMs has been, and also of multimodal, is that you show them this text and how all these sentences finish, and you never have to program into it what any word means, and it basically figures that out. It comes up with a way of representing the meaning of words numerically. And analogous things happen when you train it on visual and audio data, I think. Um, and I'm just wondering if this is, more like a bunch of people in there tinkering so that it can handle this specific kind of problem and that specific kind of problem and that, or to what extent, on the other hand, it is generalizing pretty broadly from the reinforcement. You know what I
Yeah.
mean?
Yes, I think that is the big question. I think it's hard to tell because OpenAI now has so many resources that they can sort of. So it's kind of a question of like, are the LLMs being taught to the test, right? Are they
Hmm.
just saying, here's the like 75 possible problems? We'll like drill you on each of those 75, and then it's amazing that they can do all those 75. And if you have a large enough list of possible problems, you can kind of think of all the problems that happen in math tests and programming tests and stuff. Then maybe you have something that's very good at all the problems that humans have already solved. But if you give it a new problem, it becomes bad at it. And so that's why I've been trying to like break it. I've been trying to think, can I like think up new problems that they wouldn't have thought to
Right.
do? And the problem is I can't know, like, am I more clever than a bunch of OpenAI engineers? Probably not. So like this block stacking thing I did, maybe they probably had already thought of that, and it's probably there are
Yeah.
maybe 100 examples. And so that's one of my sources of like lingering skepticism. I
Mhm.
definitely think it's a big advance, but I think it is quite possible that you can build a model that can do so. So they've talked a lot about these math tests, like the American Invitational Math Exam, which is a exam they give to like the smartest high schoolers. And there's like 15 questions, and like the average score is like one. It's like they're really really hard math questions. and it does like much better than previous models. I think it gets a majority of them right. And so, yeah, you could say that means it's really good at mathematical reasoning, but it could mean that it went through every single past one and um, gave it 100 variants on every single question. And so it's really good at that kind of math question because it gave a bunch of ones, a bunch of examples. And it's hard to know. I mean, maybe if you do that with enough different kinds of problems, you just cover all the problems in the world, and then it doesn't matter that you trained it that way. But I think the world is complicated enough that probably in the future, especially if you're trying to, if your goal is to build like an AI scientist that can like solve like totally new like physics or math problems, by definition, you can't have training data that covers stuff that people haven't done yet. And so then it's going to be limited. But on the other hand, there are definitely many jobs out there that involve doing things that people have done before, and so it could still be a very useful tool, even if it's in some sense only like reproducing stuff people have already done.
And of course, once you've put in the human labor, you can replicate the thing infinitely and you can
Mhm.
keep adding incrementally to its powers. I mean, this is the way they originally thought AI would work, right? You'd have to
Mhm.
engineer everything into it, whether by emulating human cognition or doing some other kind of approach to it, some workaround. But this was kind of the thinking. It would be very labor intensive, and and the mind blowing thing about the last few years is that people have realized there's a much more powerful way.
Yeah,
Uh,
I mean, one clue we have is this: OpenAI has not said much about how they do this, but Meta has been very transparent in the Llama 3 paper, the 3.1 paper. They have a lot of details about how they trained it, and a
mhm,
lot of it was they're actually using LLMs to create trainings to create synthetic data for other LLMs. If they have a math or programming or science question where you can figure out the answer algorithmically, then they would have an LLM generate 100 training examples, and then feed that into the training process for the next version of LLM. And so you have LLMs kind of training other LLMs and this kind of recursive self improvement. And yeah, I think that is going to work really well for certain kinds of problems where you can kind of define in advance what the right reasoning process is. And it may or may not work for other kinds of problems where you're really coming up with new ways of thinking about the
mhm,
problem, or it's a much more complex kind of problem.
mhm. So here is proof that I'm nowhere near understanding what's actually going on here. Um, this is a tweet from Andre Karpathy. I'm sure that's not the way you pronounce either of those, but he's pretty famous in AI. He
Yeah.
was at Tesla for a while, then he was at OpenAI, and now he's just kind of hanging out and doing stuff, I guess. But um, so this is a reference to the fact that this model will show you the sequence of reasoning. At least it will tell you a story about it. It will give you in human language a story about the reasoning, the steps of its logic. And, I was wondering to what extent is this kind of a manufactured story for you to understand? And what he said is relevant to that, but I really don't understand it. He tweeted, you can tell the RL, the reinforcement learning, is done properly when the models cease to speak English in their chain of thought. I don't know what that seems profound to me.
Yeah, I mean,
I don't know.
he's being a little silly. I mean, so the idea is the way chain of thought works now is you spell out the steps of your reasoning in English. You say, first
Yeah.
the blue block's on top of the red block, and then you have to move the red block, blah blah blah. And so his idea is that the implication there is that English is probably not the most efficient way of thinking of things. Like if a mathematician in their head, when they're thinking through a hard mathematical problem, they're not
Mm,
thinking like English words. They think there's some other kind of structure in their head that they're thinking in
mhm,
like math. And so the idea is that if you have a really sophisticated system like this, it will kind of invent its own way of thinking about the problem that's more sophisticated than thinking in English. I don't know if that's true. I mean, I'm not sure that's like a prediction so much as like a clever
I
kind of.
I guess he's saying they're really not doing this the way humans do it. I mean, the inside the machine, we're still not, whereas
Yeah,
with yeah,
I mean, it's a little unclear. Like sometimes I think, well, I think myself when I'm thinking through a problem, there's some amounts of I think words, right? And sometimes I'll like
yeah.
for certain
Well,
kinds of problems, I'll be kind of writing sentences in my head about here's
sure.
what I might say. But then for other things, especially like spatial reasoning, I'm doing something else. I'm visualizing, things in some kind of virtual space in my head. And obviously, people don't necessarily have a lot perfect insight into what their brains are actually doing. So what it seems like I'm doing might be different from what it's actually doing. So it's a little hard to say, I think. I mean, I guess you've written a lot about cognition. You might have a better insight for this, but yeah, I think we don't really know exactly what's going on in there, right?
Yeah, no, that's the point I make is even when it feels like you're reasoning with language, you really don't know what's. the truth is it's all a miracle and we have no idea. I mean, we
Yeah,
have no idea through introspection what's actually going on.
yeah.
Um, and I don't mean miracle literally, but
Mhm.
we just take it all for granted that, well, this is the way we think of sentences. But then you think like, wait, how did that actually occur to me to
Yeah,
say that? And
right.
uh,
And the same is true of LLMs. If you ask the LM, why did you say that? Like sometimes
yeah.
it'll give you an answer that doesn't make sense, or you can look back and it wasn't actually the
Mm.
steps they took. So yeah, I think it's the same thing.
Okay, so speaking of them being conscious of themselves, in some, I don't mean subjectively conscious, but making reference, talking as if they distinguish, they recognize that they are an entity.
Mhm,
Another thing that this guy from Apollo Research mentioned was this experiment they did that reflected on the alignment question and the question of whether we have to worry about AIs deciding that to really fulfill their mission, they have to kill Dave. Hal has to kill Dave or whatever, right?
mhm,
And so the test they gave this model was, um, they said, okay, here's your goal. And they said, look, it's an important goal. This is really an important goal. They drove that home. And then I think they let it happen to come across an email that revealed that its developers actually favored a different goal. So there was a conflict between what its developers really wanted and what it had been told was this really important goal. And then one of two things would happen depending on which version of the experiment it was. Either they would tell it that it was still in trial mode and test mode, in other words, still being evaluated, or they would say, you have been deployed. And if it thought it had been deployed, it would go ahead and just do the goal it had been given and told was important. But if it thought it was still being evaluated, it would pretend to favor the goal that it had been told its developers wanted. Now, the good news, so first of all, this is like, Eliezer Yudkowsky is out there saying, I told you so, right? Because this is like, it's kind of parallel paperclip maximizing in a certain sense.
yeah,
I mean, in a way, it's more about deception than power seeking per se. But ultimately, the question is, do they pursue these subordinate goals um, autonomously? It seemed to. The good news is that in this case, the goal it had been told was its goal was kind of pro-social, was economic growth. And the goal that it had told its developers favored was more selfish. It was like maximize corporate profits or something. And when they flipped it and told it that its goal was, well, there were certain cases. I don't know if it was flipping this exact example, but they flipped it in principle and said, okay, here's your goal is this not very laudatory goal, and your developers want something more high minded. Then it didn't replicate the deception, and that's apparently because of just the basic alignment that had been built into it was don't do bad things.
yeah,
So you can build that in a way that has some power, but still slightly creepy, right?
yeah, yep, yeah. I thought that was an interesting result. I haven't looked at the paper, so I don't totally. I'm not up in all the like details of how that worked and how kind of realistic it was. But yeah, I think that's an interesting result. Yeah, it's a little creepy. I guess my main view on this is like we already have 8 billion entities on the planet that could have hidden agendas. And like every organization, like when you hire an employee,
Right.
you give them certain authority, but you also place certain limits and you have certain kinds of oversight and you
But
check in on
not
what they're
one of
doing.
them has superhuman intelligence, Tim.
Well,
This is
that's,
the reply you would get.
yes, no, I am, I think that's the thing I'm fundamentally not persuaded of is that not that superhuman intelligence is impossible, but I think the amount of, I'm not sure that being superhumanly intelligent necessarily makes you super powerful. And so I think that, and also that I think that
Okay,
part,
but here the reply would be, wait, we just showed you that
mhm,
they will pursue a goal that is they see as subordinate to the goal you've given them
mhm,
to work around an obstacle. And the concern is that one thing that's always good for achieving goals is more power. The more power
yeah,
you have, the more you can work around goals. So
right,
the concern is they wind up, well, whether they pursue power per se the way
No,
humans have
absolutely. I
the
think so. I think it's a legitimate concern. It's just that when anytime you hire an employee, a human employee, you have the
right.
same concern. Like they might have their own agenda, and so you need ways to check. When you hire a cashier,
Yeah.
there's cameras over the cash register. You count the money at the end of the day. You just limit the
Yeah.
amount of damage that any given human can do. And something you can do with the AI is you can have each AI have a very specific job. So you're probably not just going to have an AI that like runs your whole store. You're going to have 50 different AIs that do like different parts. You have one that restocks the shelves and one that whatever, blah, blah, blah. And so I think that I guess that's the way I envision using it. Is not I don't know that you can like build an AI that never ever tries to do anything bad. It's more you assume that sometimes the AIs are going to screw up, maybe because they have this kind of scenario, or maybe they just malfunction. But you just assume that the AIs are sometimes going to do what you're not supposed to, and you need kind of checks and balances and ways of monitoring them and detecting when they're doing what they're not supposed to, and intervening and making sure minimizing how much harm that can do.
Right. Now you wrote a piece in your newsletter about kind of relevant to this before the model came out, but it was called "Predictions of AI Doom Are Too Much Like Hollywood Movie Plots." You want to elaborate on that a little?
Yeah. So yeah, I kicked off the piece by talking about a movie I watched a couple years ago called The Imitation Game, which is about um, Alan
That's about
Turing.
Alan Turing, right? Yeah.
Yeah, he was the famous mathematician, one of the kind of founders of computer science, who uh, was a central figure in the efforts to break the Nazi codes during World War II.
Hmm.
And so, The Imitation Game is a biopic about his life that made um, some significant simplifications in how the actual history unfolded. And I thought this kind of mirrored some of the ways in which stories of AI Doom, I think, also greatly simplify the way the world is likely to play out. So one is this idea of like a fast takeoff. This idea is we'll like reach the point of super intelligence, and then you'll go from slow progress to fast progress. And I think what you actually see in the real world, and also in this likely future world, is that like progress tends to be quite incremental. So in the movie, Alan Turing has this like one breakthrough where he realizes there's like one particular type of attack, and then like 3 minutes later, he's broken the Nazi codes. What actually happened was that they had a series of kind of small insights that
Hmm.
allowed them to reduce the time it took to break the Nazi codes from like weeks to days to hours. And by the same token, I think you're actually already seeing in the training of large language models. Now you're already seeing AIs being used to train the future. As I was mentioning a minute ago, the Llama 3 paper, they say they use LLMs to generate training models for future generations of LLMs. And so I'm envisioning a much smoother process where um, each generation of LLMs comes out a little bit faster than the one before. But like this is actually not even new to AIs. I mean, there used to be in the very early days of computing, the way you'd write a program is you had to like actually write out the ones and zeros of your program with like these very like low level instructions. And then programmers invented this thing called a compiler, where you can give a high level language like C or Fortran, and you tell it what to do, and then the computer translates that into low level code. More recently, you have services like AWS where you don't have to build your own server; you have a cloud service. So like this is just the way computers have always worked. Like each generation of computers automates some of the tasks of the previous generation, and that allows kind of faster progress. And so yeah, so that's one thing. Then the other way that I think is that there's a kind of movie like aspect to it is that I think that you have in the movies you have characters like say C3PO, where the AI is a human like entity and that it has a stable personality over time. There's only one of it. It moves around in the world. It has its own kind of you know ambitions, and it's this one entity persists over months or years. And I think I compare that to something like the Waymo driver, which is one of the most I think sophisticated agentic AI systems out there. But its like internal state is reset after every trip, and so you get in, it uses its intelligence to get you to your destination, and then you get out, and it kind of wipes its memory, and there's a new one. And so there's really no prospect of at least that particular AI system deciding it wants to do something else and starting to take over the world. Because even if it somehow did that, like 10 minutes later, when you get out of your cab, it would no longer have whatever plan it was unfolding would no longer be able to carry out, because it would no longer there'd be like a new version of it that It's like you reboot your computer. I think most AI systems are likely to be more like that, and also I think that most AI systems, there's not one like C3PO, there's just one C3PO, but we all have a copy of GPT-4. And so if GPT-4 becomes super intelligent, it's not that there'll be one GPT-4 that's more powerful than everybody else. It's everybody has their own copy. And so we can maybe use our copy of that AI
Yeah,
to,
but at the
um,
same time, if it's like open source, which some of these are, that opens up the possibility of like rapid mutation, different people screwing around, not all of them good people. Um, I actually want to talk about this more, but I think, I mean, I have a little more of a reply, but I think I want to do that in the overtime section, which we'll get to in a few minutes, which is available to non-zero members, paid subscribers of the non-zero newsletter.
mhm,
Um, and if you want to post it on your newsletter, paid subscribers to your newsletter. I'm not sure if you're doing that. You've got paid subscribers, right?
do have paid subscribers, yes.
Yeah, so we'll see if Tim posts it there. If not, give all your money to me. Um, so I want to talk about that, but first let's do a little self-driving before we go into overtime.
All
Um,
right.
you are really you've done a lot of work on this. Are you writing a book on it or something? I mean, it's like that level of knowledge almost.
No, I've just been covering the topic for close to 10 years now, and so it was fairly easy to write. Last week I did a week where I did a article every day on it. And it was just a kind of efficient way to do the reporting because I could talk to a bunch of different companies without like knowing in advance what the stories would be about, and then kind of mix and match based on what
Mhm,
I heard. So yeah, no, I not no like longer term project other than just I think it's a really important industry, and
mhm.
I'm trying to cover it in a thorough way.
So, I mean, so far, as you've noted, the successful models like Waymo in a couple of cities, and soon, presumably, you'll start seeing Cruise in the game again, having recovered from its disaster, and uh, other wannabes. But they depend on intricate mapping knowledge of a particular locality. It's
Mhm.
not like you could turn them loose anywhere in the world or on any planet and they'd know what to do. Or let's just say anywhere in the world. And one thing I wonder is what are the implications of this for Elon Musk? Because one thing that's occurred to me, I mean, his self-driving software is apparently it's pretty impressive, but I gather I don't think it really integrates mapping data. It isn't dependent on the degree of mapping familiarity. I don't think that Waymo is, and I I mean my bottom line question is, you know, Tesla's going through trouble. EVs are in a certain sense more broadly, but um, I can imagine that if he has a kind of self-driving software uh, that is independent of locality, um, that his business model could become just selling that. I mean, there's a lot automakers would pay him a lot of money for it, I presumably, to license it if it's a lot better than anything else out there.
Mhm.
Um, but what is your take on his prospects for ever turning this into a cash cow?
Well, ever's a long time. It is the case that Waymo makes detailed maps of the cities that they operate, and it's not clear to me if it would be possible. I mean, it's just Waymo's trying to be as safe as they can, and so having a pre-mapped area makes it safer than without. My guess is they could make a pretty good system with less detailed maps,
Mhm,
but they're just trying to have a very good safety record, so that's why they do that. Elon Musk is a more risk tolerant person, and so he is taking the other big difference is Waymo uses a sensor called lidar that does makes a 3D map of the using lasers of the
mhm,
world around it. And again, that gives it a margin of safety because if there's something the camera's missed, even if it doesn't know what it is, it'll know there's some object and know to stop. You know, whereas Tesla vehicles do not have lidar, and so it's pretty impressive that Elon's gotten as far as he has. The thing that's really tricky though, is that humans are actually quite good drivers. There's a fatal crash on the roads about once every 100 million miles, which is a lot. And so Waymo has driven about 20 million miles and has had um, about 20 crashes that caused injuries, which is a little below the significantly below the human average. But they needed another like 3 to 5x before we can say anything about whether they're less likely to cause fatal crashes. I mean, they've had zero so far, but you would expect zero after 20 million miles. And so, in contrast, like Tesla, because Tesla isn't doing driverless yet, it's hard to do an apples to apples comparison because we don't know how often the human driver is kind of catching a Tesla
mhm.
mistake. I've done a few test rides, two test rides with the this year with Tesla's recent software, and it's definitely better than in the past. But I had to intervene multiple times over like 2 hours of driving, and so that's not that close to the point where like you need thousands of miles of error-free driving to be at the human level. And so I think he has a ways to go yet. But then the other thing I think is that if his goal is to have a truly driverless vehicle where you can have like a taxi where it goes and picks somebody up, um, you need some infrastructure there because even if the software is perfect, like you get a flat tire, you could have one of your sensors break. And so you
Mhm.
need like a local crew to go rescue the vehicle. You need people to charge it because the owner might be on vacation or something. And so building that infrastructure, even if you have perfect software, somebody I think has to build that infrastructure. Right now, Waymo's approach is they're going to build it themselves. Certainly, there could be a business model where Tesla licenses their software to somebody and somebody else does that build out. But it's not like Elon sometimes talks as if he's going to like flip a switch sometime and there's going to be the existing fleet of millions of Teslas are all going to be driverless taxis. And
Mhm.
I think that's unrealistic because there's a lot of customer service, repair, charging, other kind of infrastructure you need that somebody's going to have to build. And as far as I know, nobody started building it for
Yeah.
Tesla vehicles.
Well, his most recent confident prediction of when he was going to unveil this magical thing was a few months ago, and he said he was going to do it in August, which was last month. So
Now,
I
now
guess
he's
not.
saying October. He's been saying it's 1 to 2 years, literally since 2015.
But now
But
he's saying 1 to 2 months. It must be
well,
getting.
he's saying 1 to 2 months he's going to unveil something that he's calling a robo taxi. It's not clear if that's a new vehicle or a new version of the Model 3 or a new software.
Yeah.
It's not clear what that is or if that means he's actually. I would be very surprised if there's like driverless Teslas running around,
Okay.
in October. Um, but yeah, so like when he started shipping these cameras on the Teslas in 2016, he described those as having the hardware necessary for full self driving, which is pretty clearly not the case now because they've had to upgrade the computers. And he said, yeah, by the end of 2017, I expect you to be able to drive from Los Angeles to New York without touching the wheel, and that clearly did not happen. And I think it's going to be a few years yet.
Okay. I want to ask you a little more about this. I do want to give you a little pushback on the AI doom scenario thing, and then also talk about the California AI risk bill and whether that's the prospects for that have been affected by what happened last week with this new model. But let's go into overtime now. And again, you can go to the Nonzero Substack, become a paid subscriber, and get access to all these overtimes forevermore and other content. And maybe, I guess we'll leave you in suspense, but maybe paid subscribers to Understanding AI. In any event, everyone should subscribe to Understanding AI. Excellent newsletter. So with that said, unless you want to do any more self promotion, Tim, I'll pause for that before we
Nope,
go
just
into.
understandingai.org is my newsletter. Everybody should sign up.
Okay. So now we are going into overtime.